Welcome to the Explainer. So today we're diving into this really provocative paper from Nvidia, and it asks a pretty radical question. Is the entire AI industry betting billions and billions of dollars on the wrong kind of AI?
All right, let's just start with a number, a really big one. $57 billion. Just let that sink in. That's the record amount of money that's been poured into cloud data centers for AI just in 2024. It's a staggering figure, right?
But here's where it gets kind of weird. That massive number, it's 10 times bigger than the entire market for the AI agent services it's supposed to be supporting. So what does that tell you? This is a huge all-or-nothing bet that these giant, centralized AI models are the only way forward.
And this really sets the stage for where we are right now, you know? The reign of giant AI, these digital assistants, these automated tools, they're becoming absolutely essential to how we work.
And right now, the playbook is super simple. Almost every single AI agent you hear about runs on one single, massive, kind of do-everything brain. We call it a large language model, or LLM, and it's almost always hosted in some remote data center.
Okay, but this Nvidia paper we're digging into, it argues that this entire approach is, well, just inefficient. It's costly, and it's totally misaligned with how these agents actually work. They're proposing that the real future, it lies with a completely different kind of model. So to really get their argument, you have to understand this one key difference. On one hand, you've got LLMs, the giants. They need massive data centers to run. But then you've got small language models, or SLMs, and these are nimble enough to run really efficiently, right on your own laptop or even your phone.
And listen, the paper does not pull any punches. It makes this incredibly bold claim. It says that for the kinds of specialized, repetitive tasks that most AI agents are doing all day, these smaller models aren't just a nice alternative. No, they are the future.
Okay, a claim that bold needs some serious evidence to back it up, right? So let's get into it. What's the actual case for this radical idea? Why is small supposedly so mighty?
First off, these small models they're punching way above their weight class. Just look at these results. You've got Microsoft's Phi 2, which is matching models 10 times its size. And even crazier, Salesforce's XLAM2 is outperforming a frontier model, something like GPT-4o, on specific tasks. The power gap, it's closing, and it is closing fast.
And second, the economics of it all. They're pretty much impossible to ignore. We're talking up to 30 times cheaper. 30! You can specialize one of these for a new task overnight, not over weeks and weeks. And this is crucial. You can run them offline, on your own device. That is a total game changer for cost, for speed, and of course, for data privacy.
Okay, and this diagram really gets to the core of the whole argument. See, an AI agent, it's not just one big brain thinking deep thoughts. It's actually a language model that's acting more like a controller or a switchboard operator. It's just deciding which specific tool to use next. Should I search the web? Should I run some code? It's a very structured process, just a sequence of simple decisions and actions. And that right there leads to the core inefficiency. Using one of these massive generalist models for these narrow, repetitive tasks, it's like using a Swiss Army knife when all you need is a screwdriver. Or, hiring a brilliant physicist to do your third-grade math homework. You're using a tiny, tiny fraction of its capability, but you're paying for the whole thing. It's just massive overkill.
But of course, it can't be that simple, can it? If the case for small models is so strong, what's the argument for sticking with the giants? Why are companies making that $57 billion bet?
Well, the biggest objection you'll hear is this idea that, hey, bigger is just always better, right? The thinking goes that a larger model will always have a better, more general understanding of the world, and that makes it superior, even on those narrow tasks. It just knows more stuff. And to be fair, this view rests on some really solid foundations. You've got these scaling laws from decades of research that basically show, yeah, as models get bigger, they get better. And then there's this fascinating idea that these huge LLMs develop what are called semantic hubs. It's like a deeper, more abstract kind of intelligence that allows for really nuanced reasoning, the kind of thing a smaller model might just not be able to do. But the paper has a rebuttal for every single one of these points. It argues that, first, new, smarter architectures are totally changing the whole scaling law game.
Second, a quickly specialized small model can absolutely beat a generalist giant on a specific task. And third, the agents themselves break down complex problems into simple steps, so all that deep abstract reasoning, a lot of the time, it's just not needed.
So, that brings us to the big question, doesn't it? If these SLMs are so powerful, so economical, and such a better fit for the job, why isn't everybody using them already? What's the holdup?
Well, the paper points to three main hurdles here. First up, simple inertia. Remember that $57 billion? It's already been spent, and it has to go somewhere. Second, we're using the wrong kinds of tests. We're basically judging a fish on its ability to climb a tree. We're judging a specialist by a generalist's exam. And finally, there's just a lack of awareness. Let's be honest, the giant models get all the hype and all the headlines.
But here's the good news. The paper argues these are just practical hurdles. They're not fundamental, show-stopping flaws. And the best part? It doesn't just diagnose the problem and leave it there. It actually offers a practical roadmap for how the entire industry can make this switch.
So, how does a company actually do this? Well, the authors lay out this really elegant 6-step process they call a conversion algorithm. It's basically a continuous improvement loop. You start by just logging all the simple, repetitive stuff your expensive LLM is asked to do. Then you collect that data, find the common tasks, and train a cheap, fast, specialized little SLM to take over that one job. What happens then? You free up your expensive general-purpose model to work on only the truly complex problems.
And the end result of all this is a much smarter, more modular system. Instead of relying on one giant, expensive, monolithic brain, you end up building this flexible team of tiny, super efficient experts. It's kind of like a box of Legos, right? You can just snap them together to build whatever it is you need.
So, this all leaves us with a really provocative final thought. What if we've all been chasing the wrong vision for AI? What if the future isn't one giant, all-knowing, God-like mind in the cloud, but instead it's a decentralized, super efficient, and way more accessible swarm of tiny, specialized experts all working together? It's definitely something to think about. Thanks for joining us on The Explainer.